So the next question is explain acid properties of transition. A transition is an atomic unit of work that is either completed in its entirety or not done at all. So transition having four properties, they are known as acid, and A is for atomicity, C is for consistency, I is for isolation, D is for durability. So first of all, we'll see what is atomicity. Atomicity, a transition is an atomic unit of processing. It is either performed in its entirety or not performed at all. That means either the complete instructions are going to be executed and the transition is going to be, database is going to be in consistent state, or no effect of execution of partial statements are in the database. So let's say we'll see with one example. Here one example is transaction to transfer rupees 100 from account X to account Y. So you can see here these are the statements which are for transferring 100 rupees from X to Y. First we have to read X, then we are going to reduce 100 rupees from X, then write X, read Y, then 100 rupees addition is being done on Y's account, and finally write Y. Now if after step 3 and before step 6 transition fails, then the money is going to be lost, if you see, and the inconsistent database stage is there. So here if you see, let's say in starting the value of X is going to be 500 and Y is 200. So after the execution of second statement and third statement, the state of X is going to be 400, but if transition fails after third statement, then we have a state of Y is going to be 200. So finally we'll have inconsistent state is there, because inconsistent state Y, because sum of A plus B before transition must be same after completion of the transaction. So here you can see sum of A plus B is 700 before transaction. That means A is X plus Y, and then after transition X plus Y is going to be 600. So that is not consistent. Here that is the property of atomicity. So that means if transition fails after step 3rd and before step 6, money will lost, leading to an inconsistent database state. Failure could be due to any cause, either it will be software or hardware. The system should ensure that updates of partially executed transition are not reflected in the database. So the next property is consistency preservance. Correct execution of the transition must take the database from one consistent state to another. So if the execution of the transition is correct, then it must take the transition from one consistent state to another. Meaning by this, we'll see with one example here. So suppose we have these instructions: read X, then we are transferring 100 rupees from X to Y. So reduction of 100 rupees from X, then write X, read Y, and addition of 100 rupees to Y and write Y. So what is the meaning of consistency here in this example? Sum of X plus Y is unchanged by the execution of the transition. That means sum of X plus Y before transition must be same after transition. So let's say the value of X is 500 and Y is 200. Then if you're going to complete the complete instructions properly, then we have X is equal to 400 and Y is equal to 300, because we are transferring 100 rupees from X to Y. So you can see here this is going to be consistent, because if you see here 500 plus 200 is going to be 700. Also 400 plus 300 is 700. So if transition is going to complete consistently, then sum of X plus Y before starting of the transition and after completion of the transition is going to be unchanged. That means same. So that is why it is going to be consistent. But if it fails after 3 and before 6, then it is going to be in inconsistent state, and in that scenario we will have the value of X is going to be 400 and Y is going to be 200, because we have not yet updated the value of Y. So it is going to be inconsistent state if any failure occurs up between 3 to 6. So during transition execution, the database must be temporarily inconsistent. So in that scenario, it is going to be inconsistent during execution of the transition. When the transition completes successfully, the database must be consistent. That is the property of ACID, consistency property.
So the next property is isolation. A transaction should not make its updates visible to other transactions until it is committed. So this is the property which says that even though multiple transactions may execute concurrently, the system guarantees that for every pair of transaction, here we have two transactions T1 and T2. So it appears that T1 either finished first, then T2 start, or T2 finished first, then T1 start. So it is like that each transaction are running serially. So that is isolation field of that. So this property, when enforced strictly, solves the temporary update problem and make cascading rollbacks of transition unnecessary. So if you see here, if between step 3 and 6, under transition T2 is allowed to access the partially updated value of the X, then it will give an inconsistent database, that is sum of X plus Y a, B will be less than it should be. So here if you see here, so if in between, if another transition T2 read the value of X, and this X is going to be, let's say 500 we have already, so it is going to be 400, Y is going to be 200, so sum is going to be 600, which is not consistent because we have not completed the T1 and T2 has taken the value in between, so it is not going to give the inconsistent values. So that is the isolation. That means if one transition is running, then its update are not visible to another transition until it is going to commit it. And last one is durability. Durability means once a transition changes the database and the changes are committed, then the changes must never be lost even if there are any system failures, either any software failure or hardware failure or any catastrophic failure, the data is not going to lose. So that is known as durability.